Today, we'll learn how the staff at one fictional organization, the Great Outdoors Company, takes advantage of InfoSphere Optim integrated data management solutions for performance management to help them work collaboratively to gain more value from their business-critical applications. You will see how the team resolves an emergent database workload performance problem, accelerates the performance and stability of the application without requiring code changes, and builds performance into a new application right from the start, thereby reducing downstream risks and costs. It's not been a good day at the Great Outdoors Company. The manager in charge of customer service is upset because they are unable to meet their goals for average call time. The customer service reps say that the application that retrieves the customer order history is taking way too long. Managers are calling managers, and Jackie, the DBA, is called in to figure out what is going on. Jackie logs on to the system that mimics the production system environment to monitor the performance of this customer order history application. From the SQL activity report and based on the user ID running this application, she notices that the application workload takes more than 4 minutes in elapsed time and 49 seconds in CPU time. The workload highlight shows a large number of scans, I/O requests, and suspends. Scrolling down, Jackie sees that most of the elapsed time was spent on DB2 and suspended waiting time. The detailed Class 2 DB2 time shows that most of the workload time was spent on suspended waiting time and CPU. From this performance data, Jackie decides to use Optim Query Workload Tuner to tune the application workload. There are 4 basic steps in the query workload tuning process. First, capture SQL statements for analysis and tuning. Second, schedule an explain task to collect statistics information for all SQL statements in the workload. Third, use the workload advisors to analyze performance and get recommendations for areas of improvement. Finally, review the recommendations, tune the workload using generated scripts, and revise the SQL statements based on the recommendations. All these steps are made easy with the new Query Tuner Workflow Assistant in the Optim Query Tuner client. Let's see how Jackie uses Optim Query Workload Tuner to analyze and tune the problem SQL workload. First, Jackie starts the tuning process from the database that the applications run against. The Query Tuner Workflow Assistant is where you capture and analyze the statements that need to be tuned. Different tuning features are grouped into sections that you open by clicking tabs on the left side of the Workflow Assistant. The Workflow Assistant opens some of the sections automatically as you progress from one stage of the tuning process to the next. You can also open a section directly to use the features available in that section. You can create a query workload that contains SQL statements from various sources. In this example, Jackie captures SQL statements from the statement cache and filters by the user running the application that causes a performance problem. The captured statements are shown. Jackie then saves them in a query workload. Next, Jackie runs the explain facility on the query workload to get access path information for the statements. After the explain task is completed, Jackie runs the workload statistics advisor first to follow best practices. This advisor collects a full set of statistics for the objects related to all SQL statements in the workload and provides a consolidated set of statistics recommendations that apply to the entire workload. After the workload statistics advisor is finished, Jackie looks into the detailed recommendations and sees a set of run stats control statements that she can run to improve the performance of the workload as a whole. The detailed report shows statistics information for each of the database objects used in the workload, such as missing, incomplete, obsolete, and conflicting statistics that might lead to suboptimal performance for the SQL statements in the workload. Details of conflicting statistics are also provided for Jackie's analysis. After analyzing the workload statistics advisor's report and recommendations, Jackie runs the run stats control statements provided to collect a complete set of statistics. After accurate and up-to-date statistics for the workload have been collected, Jackie runs the Workload Index Advisor, which considers all SQL statements in the query workload and looks for ways to improve the performance of the workload through index usages. She also runs the Workload Query Advisor, which compares SQL statements with a set of best practices and recommends ways to rewrite SQL statements in the workload to improve its performance. After the advisors finish, Jackie looks at the Workload Advisor recommendation summary and notices that the Workload Statistics Advisor automatically updates the explain results. The statistics are current. She drills down to the Workload Query Advisor section, which shows a summary of the analyzed queries in the workload. She then drills down to the statements with the highest severity warnings and starts to analyze the recommendations for the statements that take a long time to run or run the most often. There are 3 recommendations for this query, with exclude options to tell the Workload Query Advisor to ignore any of these rules when analyzing the workload for recommendations. The first recommendation suggests adding a predicate to the cust code column. Detailed explanations are provided along with examples. Jackie continues to analyze other recommendations and then moves on to the Workload Index Advisor recommendations. The top of the Workload Index Advisor section shows that Jackie can gain a 15% performance improvement for the entire workload, requiring only 90 megabytes of disk space if all the recommended indexes are created. There is a list of recommended indexes with the estimated performance improvement and disk space for each of the recommended indexes. For each of the recommended indexes, Jackie can drill down to see which query statements would benefit from this recommended index. The Workload Index Advisor also shows a list of existing indexes related to all the tables referenced in the workload, with indicators to show whether these indexes were used by any of these statements. The Workload Index Advisor also shows a list of indexes used by the optimizer but not recommended by the advisor. There are also brief codes for the reasons these indexes are not recommended. In this example, these indexes are not recommended because the estimated performance improvement is less than the benefit threshold defined in the customizable options in the Workload Index Advisor. Jackie runs the DDL to create the recommended indexes. Finally, she monitors the application, analyzes the SQL activity report again, and is extremely happy to see the performance has improved significantly from 4 minutes to 16 seconds. With its intuitive and iterative tuning interface, IBM Optim Query Workload Tuner for z/OS can help DBAs and developers maximize application performance by using expert advisors and tools while increasing customer satisfaction, productivity, and quality of service. Using Optim Query Workload Tuner, you can reduce the total costs of ownership for DB2 for z/OS servers by speeding up query analysis and tuning, reducing specialized skill requirements, and optimizing system availability, minimizing use of hardware, software, and human resources. While looking at the improved performance of the application in the SQL activity report, Jackie notices there are some prepare statements. Having learned that the application processes SQL that includes lots of literals, she believes that replacing them with parameter markers would reduce the prepare overhead. Instead of asking the application team to recode the application, Jackie decides to see what she can do to optimize and stabilize performance by using the client optimization capability available with Optim Pure Query Runtime. Jackie will use a common Pure Query client optimization process that consists of capturing the SQL statements that are executed by an application into a central repository, defining the mapping from SQL to database packages, binding the captured SQL statements into packages on the target database, and finally, configuring the runtime environment to run SQL statements statically by exploiting the packages that were created. Now let's catch up with what Jackie is doing. In the application configuration that was created for the initial client optimization process, Jackie wants to configure the Pure Query runtime to capture the SQL statements while the application runs the statements dynamically. She presses the Control and Space keys to use the Content Assist function, which provides the list of available options along with detailed explanations for these options. In this example, she also wants to capture more detailed information about the source code that invokes the SQL, and, if possible, replace the SQL statement literals with parameter markers. She saves the configuration and then uploads it to the central repository. After the application is run and the dynamic SQL statements are captured, Jackie needs to merge the captured SQL statements and define a package mapping. First, she inspects the captured record entry with the Not Processed status. This status means that Pure Query has captured new information about the originating application, but it hasn't been processed yet. Next, she defines a mapping between the captured SQL and a database package, along with the desired package characteristics such as the collection in which it will reside. She then applies the changes to the package mapping. Next, Jackie wants to review the captured SQL statements. She notices the literal values were successfully replaced with parameter markers. She can work with the SQL by running it, editing it, exporting it, or explaining it. Next, Jackie inspects the change report that outlines which packages need to be created or modified to reflect the current state of the application. Details of the package changes are also provided. Then, Jackie selects the database connection in which she wants to create the necessary database packages and binds the packages. Once this completes, DB2 can run the application's SQL statically. Jackie then modifies the behavior of the Pure Query runtime environment by disabling SQL capturing and switching to a static SQL execution mode. She decides to save this new configuration as a new version in the repository, allowing her to switch back to her previous configuration at a later time. Finally, Jackie uploads the modified application configuration and activates it. Once the configuration is activated, the Pure Query enabled application will retrieve the new information and start processing SQL in static execution mode. Later, after the application runs, Jackie uses the SQL activity report once again to analyze the application performance and sees that the total elapsed time for the application has been reduced to 13 seconds from 16 seconds. She also notices that no more prepare statements are in the SQL activity report. Jackie is happy that by simply using client optimization, the application has gained 18% improvement in performance. By using Pure Query client optimization, DBAs can proactively optimize and secure database applications, helping to reduce costs for growing applications. Performance testing has shown that Pure Query static execution can significantly increase database transaction throughput and reduce CPU consumption. Increasing efficiency allows more work to be loaded onto existing hardware. And by using static execution, the improved performance can be locked in, securing quality of service. The unique correlation between the application and its associated database packages simplifies common database monitoring and administration tasks. Finally, auditability and security are improved. Captured SQL statements can be reviewed for audit purposes, and the security risk of dynamic SQL injection is reduced by using static SQL. All of these benefits are possible without changing any application code. The Great Outdoors Company is implementing a new application to support their growing business partner relationships. The development and DBA staff that is working on the new application has decided to collaborate on the project by using Optim solutions to create applications that build in best practices for databases and performance from the start. Optim solutions can help the team collaborate on performance considerations earlier in the cycle, where it is cheaper and less disruptive to find and correct, reducing the overall risk for the project while enhancing developer productivity and agility. Let's see how the premier database development environment provided by Optim Development Studio and Pure Query gives unique performance insights to database developers and DBAs. After a user runs the application, actual data about performance can be collected and viewed. Here, Roslyn, the database developer, can see the performance data and quickly see the SQL statements that are most frequently run or have the longest elapsed times. She can sort in the table view to easily locate data access hotspots in large applications. If needed, she can save the performance data to compare with other runs. She can also view explain data to find the most expensive SQL statements. For these SQL statements, database developers can use available tasks such as the integrated Optim query tuner for tuning an individual SQL statement or exporting SQL statements to a file to tune workloads. In this example, Roslyn can relocate directly to the corresponding place in the Java source code. It's also easy to find out which tables are used in the query, so developers and DBAs can understand the impact of database changes on the application or investigate the characteristics of the table, including data distribution. Roslyn can also easily filter out SQL statements that access specific columns, which helps her isolate problems and analyze the impact of changes. Optim Development Studio enables a powerhouse Java development environment that moves database performance front and center with capabilities such as easy identification of SQL hotspots and a seamless switch to static SQL. DBAs and developers can collaborate effectively on performance early in the application development cycle, using graphs and reports to efficiently communicate the information a DBA needs to help tune queries. Finally, Optim Development Studio can improve productivity and reduce risk by using database-centric tooling that helps prevent coding errors and makes dependency analysis a snap. Optim helps developers create Java applications that even DBAs will like. We've seen how the performance management solution by InfoSphere Optim has helped the Great Outdoors Company reduce costs, reduce risk, and improve agility by enabling the staff to work collaboratively to resolve problems more efficiently and proactively, make existing applications faster and more stable, and build new applications that are streamlined and optimized for database access. To find more information about IBM Optim Query Workload Tuner, Optim Development Studio, and Optim Pure Query Runtime, or how other integrated data management solutions can help you manage the data and database application lifecycle, click on the available resources shown here.